Hello, geometry students. Today we're going to be using all we learned about the definition of similarity to find missing side lengths in similar shapes. So the first thing I want to do is talk about this situation. So here we are given that these two triangles are similar. And that means that we can mark all the corresponding parts. We see angle B has to be congruent to angle E. So even though it's not marked in there, we could mark that in based on the similarity statement we're given. And now since we're given that, we know that all corresponding sides will be in proportion as well. And so the first thing we want to do is figure out the scale factor. And the way we can figure out the scale factor is to find two corresponding sides that both have a number on them or a length. In this example, we see that this is the length of BC in between the 3 scratch, 2 scratch, and that corresponds over here to EF, which is in between its 3 scratch, 2 scratch. And if you reduce that fraction by taking an 8 out of both, you see that it's a 3-to-2 comparison between these two shapes, the side lengths. And because we're told that they're similar up here in this similarity statement, we know that every pair of corresponding sides has to have a 3-to-2 ratio. Now notice, order matters, and I went from the left to the right. I went big shape to little shape. And so I have to always make that comparison. And so now I can say, well, 3-to-2 has to be the same as 21 to x. 21 to x. And now we can use our properties of proportions to solve this. Product of the means equals product of the extremes. And then we can divide both sides by 3 in order to get our final answer. 3 goes into 21 7 times, and 2 times 7 is 14. And so we see x equals 14. All right, how about these two triangles? You try it on your own paper and then press play when you are done. I would start by putting marks using the similarity statement we're given to put congruent marks on the corresponding angles, because we know when shapes are similar, their corresponding angles are congruent. And then I would put marks on the side lengths that correspond to one another. We can see that the HG is in between the 2 scratch, 3 scratch, and PN is in between its 2 scratch, 3 scratch. So 20 is going to compare to 10. And so we see our scale factor is 2-to-1. Now notice, we want to find X, and X is in between its 3 scratch, 1 scratch. So MN is corresponding to FG. But notice in our original comparison, we went big to little. So we have to continue going big to little. So 12 to X. And now we can use our properties of proportion. Product of the means equals product of the extremes. And then you can solve, and X is going to equal 6. Now, pause, find X and Y, and then press play. I recommend you start by putting marks on the corresponding sides so we know visually which sides correspond to each other when we make our comparisons and our extended proportion and our ratios. All right, so we are looking for a pair of corresponding sides that each have a number. 4 and 6 fit the bill in between the 3 scratch and the naked angle. And so we see that the scale factor is 2-to-3. And so 2 is to 3 as X is to 9. And we can use our product of the means equals product of the extremes and solve for X. We can do the whole shebang again for Y, because 2 is to 3 as Y is to 12. And we can do product of the means equals product of the extremes, and y is 8. Pause, find A and B, and then press play. You want to start this problem by marking your diagram. We see vertical angles are congruent, and those marks help us see which sides are corresponding to each other. Be careful because these triangles are rotated in space. And so A corresponds to the side that measures 12 in the other triangle. And so next we look for the two corresponding sides that each have a number, and we see that that is the 9 and the 15 are both in between the 1 scratch, 3 scratch. And so now we know the scale factor between these two shapes is 3 to 5. And notice we went left to right or little to big, and so we have to always do that order. So 3 is to 5 as A is to 12. And so now we can use our product of the means equals product of the extremes, and we can solve for our answer. And you can leave it as a fraction. Let's do the whole thing again for B. 3 is to 5 as B is to 10. Product of the means equals product of the extremes, and so B equals 6. And our final problem of the day, let's try with some little bit of algebraic expressions involved. Here we're given this similarity statement. And so we know from the similarity statement that JK corresponds to QR. And so right away we know we have a 3 to 9 or 1 to 3 is our scale factor. Excuse me, that should be a 3. So 1 to 3 is our comparison. And notice we went left to right or little to big. And so when we're trying to compare Z, that corresponds to Z plus 4. And now we're going to use our properties of proportions to solve. Product of the means equals the product of the extremes. And then we're going to subtract Z from both sides and divide both sides by 2 to get our final answer. And so I will leave you with these penguins and wish you a great day.